Hi, this is Calandra. In this video, we'll cover what complex numbers are and how to find the square root of negative numbers. So what are complex numbers? Complex numbers contain all real numbers, but also the imaginary numbers. So in mathematics, the imaginary number I is defined to be the square root of -1. So equivalently, I squared is equal to -1. So we know that it's not possible to square a real number and have a negative result. This only happens with imaginary numbers. All complex numbers can be written in the form a plus bi, where a and b are real numbers. Okay, so every real number is a complex number. So for example, the number 7 can be written as 7 plus 0i. So we can see that every real number is also a complex number. In this example, we are to simplify the following expressions. So we want to be mindful that the imaginary number I is equal to the square root of -1. Okay, so the first thing I'm going to do in evaluating the square root of -16 is rewrite it as the square root of -1 times 16. And then we can break this up into the square root of -1 times the square root of 16. So by definition that we just went over, the square root of -1 is equal to I. The square root of 16 is equal to 4. Well, I times 4, we would just write as 4i, the same as we would a variable. And that would be our answer. Okay, so the square root of -16 is equal to 4i. Okay, part B, we can do the same thing. We know that the square root of -81 is the same as the square root of -1 times 81. So I can break this up into two radicals, the square root of -1 times the square root of 81. By definition, the square root of -1 is I. We know that the square root of 81 is 9, and then I times 9 we would just write as 9i. So notice that when you have a negative under your square root, your final answer will end up with an I, and then you would find the square root of the numerical part the way that you always would. So when I look at part C, I know that I'm going to have I as part of my answer. So the only question is, how do we find the square root of 24? So 24 is not a perfect square, so we have to do a little bit more work with this one. So I'll go ahead and rewrite it the way that we did the others. So -1 times 24. Okay, well, instead of writing the square root of -1, I know that I'm going to end up with an I based on the last two examples. Times, and we still have that square root of 24 to deal with. Well, 24 is the same thing as 6 times 4. So we could rewrite this as square root of 6 times square root of 4. But the square root of 4 is just equal to 2. So I'm going to take that out. Actually, let me go ahead and write it out. I'm going to change my order just to make it look a little bit nicer, although it doesn't matter. So this is equal to I times the square root of 4 times the square root of 6. So we end up with I times 2 times the square root of 6. So the way that we would write this, our final answer would be 2i square root of 6. For part D, when you're dealing with imaginary numbers, you cannot go in the reverse order where you start with a product and then multiply the radicands together. Because if I did that in this case, I would just end up with the square root of 16, which doesn't take into account that we're dealing with imaginary numbers when you have a negative under the square root. So the first thing that we need to do is deal with the negative under the square root. Well, from the previous problems, I know that to get rid of the negative, that means we're going to take an I out, and I'm left with 2 under the radical. Similarly, for my next one, I know that the square root of -1 is going to become I, and I still have square root of 8 under the radical. Now remember, all of these are multiplication, so you can write that if you need a reminder. Well, I times I is I squared. And now that we're dealing with real numbers, we can go ahead and multiply the 2 times 8 to get the square root of 16. Well, by definition that we went over, I squared is equal to -1. The square root of 16 is 4. So we end up with our final answer of -4. Okay, so notice we would not have come up with that if we multiplied our radicands together as our first step. So when you're dealing with imaginary numbers, you need to get it in terms of I before you multiply your radicals together. Okay, for part E, we have a negative outside of our radical. I see a negative under my square root, so I know I can go ahead and bring an I out, and I still have the square root of 36. Well, you may have been able to do all of this in one step. The square root of 36 is just 6, so we can write that as -6i. Okay, if you wanted to, let me throw in an extra step, just in case this would be helpful for somebody. So we have -I times square root of 36, which is 6, and then we just write it in a better form, -6i. Okay, for part F, we have I square root of -5 squared. Well, whenever you have something squared, I suggest that you start off by writing the something times itself. Okay, so now, based on what we talked about in example D, we know that we need to deal with that negative that's under the radical. That means we're going to be able to pull an I out. I'm also just going to put my times signs in between the I and the square root, just as a reminder that that's a product. So I have my initial I. When I take the negative outside of the square root, that becomes an I, and I'm left with a positive value, square root of 5 times. Similarly, we have the initial I times, you take a negative out of the square root, that becomes an I, and we still have square root of 5. Okay, well, I times I is I squared, still have the square root of 5, times, again, I times I is I squared, and we still have the square root of 5. I squared is equal to -1 times, well, I know I'm going to have another -1, so I'm going to go ahead and write it, times square root of 5 times square root of 5 is the square root of 25. We can multiply since we're dealing with real numbers now. Well, the two negatives are going to cancel out and leave me with a positive, and the square root of 25 is just 5, and that would be our answer. When adding and subtracting complex numbers, follow the same rules of combining variable terms. So you're just going to combine your coefficients and your real numbers together. So write the following expressions in the form a plus bi. So in part A, we're looking for our like terms, which are 4 and 6, and -3i plus 5i. So 4 plus 6 is 10. -3i plus 5i is 2i, and that's in the form that was specified, and that would be our answer. In part B, we have something squared. So remember from that earlier problem, my hint to you is to go ahead and write it as a product of it and itself. So when you write it this way, then hopefully that'll help you to remember that you need to use FOIL or the distributive property, however you want to think about that. So when we do first times first, that's 1. Outer times outer, is negative 3i. Inner times inner is another negative 3i. And last times last is plus 9i squared. So negative 3i minus 3i, we're treating it just like a variable to get negative 6i, plus 9. Now we don't want to leave that I squared. I squared is defined to be negative 1, so we need to plug that in. So we have 1 minus 6i minus 9, which gives us a final answer of negative 8 minus 6i. Our last example, we see that we have some square roots with negatives underneath, so I know I need to get those in terms of I. So the first radical I can rewrite as I square root of 1 plus 9 minus, to bring the square root out, it becomes an to bring the negative out of the square root, it becomes an I, and we're still left with 9 under the radical. The square root of 1 is just 1. 1 times I is I. I still have my plus 9. The square root of 9 is 3, so I times 3 is 3i. So you can always write your coefficient of 1 if you need to. So remember that we have an understood 1 there. So when we have I minus 3i, it'll give us a negative 2i. But to put it in the form requested, let's start with our real number, 9, and then we'll have minus 2i. You don't need to do plus a minus 2i. This would satisfy that form.